Water is the most abundant compound on Earth's surface, covering 70% of the planet. In nature, water exists in liquid, solid, and gaseous states. It is in dynamic equilibrium between the liquid and gas states at standard temperature and pressure. At room temperature, it is a tasteless and odorless liquid, nearly colorless with a hint of blue. Many substances dissolve in water and it is commonly referred to as the universal solvent. Because of this, water in nature and in use is rarely pure, and some properties may vary from those of the pure substance. However, there are also many compounds that are essentially, if not completely, insoluble in water. Water is the only common substance found naturally in all three common states of matter, and it is essential for all life on Earth. Water makes up 55% to 78% of the human body. Forms of water. Like many substances, water can take numerous forms that are broadly categorized by phase of matter. The liquid phase is the most common among water's phases and is the form that is generally denoted by the word water. The solid phase of water is known as ice and commonly takes the structure of hard, amalgamated crystals, such as ice cubes, or loosely accumulated granular crystals, like snow. For a list of the many different crystalline and amorphous forms of solid H2O, see the article ice. The gaseous phase of water is known as water vapor, and is characterized by water assuming the configuration of a transparent cloud. The fourth state of water, that of a supercritical fluid, is much less common than the other three and only rarely occurs in nature. In extremely uninhabitable conditions, when water achieves a specific critical temperature and a specific critical pressure, liquid and gas phase merge to one homogeneous fluid phase, with properties of both gas and liquid. One example of naturally occurring supercritical water is found in the hottest parts of deep water hydrothermal vents, in which water is heated to the critical temperature by scalding volcanic plumes and achieves the critical pressure because of the crushing weight of the ocean at the extreme depths at which the vents are located. Additionally, anywhere there is volcanic activity below a depth of 2.25 kilometers can be expected to have water in the supercritical phase. Vienna Standard Mean Ocean water is the current international standard for water isotopes. Naturally occurring water is almost completely composed of the neutron-less hydrogen isotope protium. Only 155 ppm include deuterium, a hydrogen isotope with one neutron, and fewer than 20 parts per quintillion include tritium, which has two. In keeping with the basic rules of chemical nomenclature, water would have a systematic name of dihydrogen monoxide. But this is not among the names published by the International Union of Pure and Applied Chemistry, and, rather than being used in a chemical context, the name is almost exclusively used as a humorous way to refer to water. Heavy water is water with a higher than average deuterium content, up to 100%. Chemically, it is similar but not identical to normal water. This is because the nucleus of deuterium is twice as heavy as protium, and this causes noticeable differences in bonding energies. Because water molecules exchange hydrogen atoms with one another, hydrogen deuterium oxide is much more common in low-purity heavy water than pure deuterium monoxide. Humans are generally unaware of taste differences, but sometimes report a burning sensation or sweet flavor. Rats, however, are able to avoid heavy water by smell. Toxic to many animals, heavy water is used in the nuclear reactor industry to moderate neutrons. Light water reactors are also common, where light simply designates normal water. Light water more specifically refers to deuterium-depleted water. Water in which the deuterium content has been reduced below the standard 155 ppm level.